So let's go ahead and practice. I'm gonna put, this is check your, put up a picture. Do I have a picture? Yeah. So in your notes, if you printed it or got a hard copy, we're gonna do this example together today. So I've got, this is in your notes. Does anyone need this or need a digital copy or anything? Drop it in the chat and I can get you the link. We're going to do check your understanding number 2 today, because we didn't do that yesterday. We just did the first one. So it's like a couple pages into your packet. We're going to do this one, and then you guys are going to practice one, and then you're going to be off for stats for the week. Okay. Oh, goodness. Share this tab. See, I already did it. This is what you want. Check your understanding number 2. This is what we're doing. This page. It might be split between 2 pages. I don't know. I already see. I didn't hit the. Anyone need this? No? Great. If you do, put it in the chat. I'll give you the link. Okay, share this tab instead. So this is check your understanding number 2. We are going to kind of do this together. So I am going to call on just some of you randomly to help kind of walk through this together, and so we can think through the process together. And then you're going to try one, and then you're going to be done. So, okay, I'm going to read this. We have pennies made prior to 1982. So if you ever had me in chemistry a couple years ago, this is a classic chemistry lab that we do with copper pennies, because they switched the content of pennies in 1982. That used to be 95% copper, but copper is expensive. So because of their copper content, these pennies are worth about that much each. Pennies made after 1982 are only 2.5% copper. Jenna reads online that 13.2% of pennies in circulation, so this would be every penny in the United States ever made, are pre-1982 copper pennies. So if you find one of these, they actually are heavier than the pennies you have today, if you even have pennies. Like, who has cash anymore? Okay, so Jenna has a large container of pennies at home. She selects a random sample of 50 pennies from the container and finds that 11 are pre-1982. Does this provide convincing evidence that the proportion of pennies in her container is greater than the 13.2% or the greater than 0.132? So basically, Jenna's got some pennies, and she's wanting to investigate to see, is the true amount of copper pennies out there, is that really 13.2%? So let's describe in words first. Let's take an inventory of the information we've got to kind of figure out what we're doing, because this can be confusing. So the population of pennies, that is any penny ever made. So for the population, we have all U.S. pennies. So for every question that we do second semester, you're going to have to do this first step. So I'm going to stop after this first step and see if you have any questions, because this first step is what you have to do every single time you do a question this semester. It's take an inventory of what you've got. So we've all U.S. pennies. What is my sample size? So what sample did I take for this one? Ben, do you mind unmuting yourself? Hopefully you're there. How many pennies do I have in my sample? What do we got?
It's 50, right?
It is 50, yeah. So 50 pennies. Boom. All right. So you just got to find that number. So notice the population doesn't have a number. It's just all pennies in circulation in the United States. So you won't always have a number for your population. That's fine. You just have to describe it in words. All right. So what now for statistic and parameter, we generally have a number for both of those. So the parameter, notice I put it next to population. They both start with P. Parameter is what we're measuring, or the measurement we think we have from the population. So in this case, it's the true proportion of pennies, which gets a P symbol. So we do have to watch our symbols, because in stats, certain symbols mean certain things. So to a statistician, if I put P here, instead of P with a little hat over it, that would indicate to me that I know, oh, this is the measurement from the whole population. That's important. It's not from a sample. So in this case, our proportion of pennies that we think exist that are from, all copper pennies pre-1982 is 13.2%, so 0.132. Now for my statistic, that is whatever I get from my sample. Now it's winter, got to put a hat on. So P with a little hat over it, P hat is what we call it. What is that one? So that's from the measurement she gets from her sample that I can write as the fraction, a decimal, however. So what did she get out of her sample? McGowan, somebody saw. What's our P hat? What did she get from her sample? Do you mind unmuting yourself? Lillian, we'll try you. Lillian, do you mind unmuting yourself? What did Jenna get for her sample? How many pennies out of
11 out of 50, and I use my calculator, and that's 0.22.
Bless your heart. I didn't bring my calculator with me today, so that's good. All right, we got 0.22. So now we're looking at it. So notice I'm with my appropriate symbols, I'm measuring proportions. They gave me percentages, like proportion of things, fractions. So I'm using these symbols. I'm not using anything with the mean. Because I'm not measuring like the average number of pennies. I'm measuring the proportion of pennies. So that's why I'm using these symbols. So this is our inventory that we're literally going to have to do before we start every single question in stats this semester. So what questions do we have about this? Feel free to hit the raise hand button and ask, or drop it in the chat. Any questions here? Because this is one of the most important parts of taking your inventory of what you've got. Okay, so let's go ahead. This got very large all of a sudden. So let's look at the next question. So, yeah, great question, Jessa. Well, you need to write in complete sentences. No. If you write this one this way, this should count. But you have to use context. If you don't use context, you're all done. So if you clearly do set it up this way, it should be fine. But if you don't put context, your ship is sunk. So you've got to make sure you put pennies in there, the context. Okay. So let's look at number 2, because if we notice, her proportion of like all copper pennies she got is a lot greater than what the population number is, right? So that's a little wacky. Like, whoa, we got a whole bunch of pennies in our sample, 22%, and we thought only 13.2% were in circulation that were copper, but our sample was a little nuts. So Jenna does have some evidence, or does she have some evidence that there are more, than 13% of her copper pennies. So what do we think? Does Jenna have some evidence, and what is her evidence? That there are more than 13.2% of copper pennies. What are our thoughts? On somebody, Aiden, I haven't heard your voice in a while. What do you think? Does she have any evidence that there's more than 13.2% of pennies pre-1982? What do you think? Yes or no? Do you mind unmuting yourself? Oh, great. Okay, well, yep, we are holding. Maybe Poppy's fighting you for the computer or something. I don't know. Thanks for using the chat. That's all. Oh, okay. I'll come back to you, Aiden. Thanks for using the chat. That's fine. popping at your house this early in the morning. Chris, let's go with you. What do you think? Does Jenna have some evidence that there are more than 13.2% of pennies that are pre-1982? Yes or no? What do you think? Go with your gut. Do you mind unmuting?
I'd say not necessarily because of how small of a sample size it is.
Okay, fair. So like we only took 50, right? And it's not a guarantee that every single sample is going to be exactly 13.2%. So her sample could just be a little wacky, right? You know, she only took 50. There's probably millions of pennies in circulation. So maybe the sample size has something to do with it, sure. So we can, this one's a little open-ended. You can kind of say like, well, yeah, maybe, maybe not. I would say maybe, because her p hat is a lot greater than the population proportion. Now that being said, though, Chris's thought is valid in the sense of, well, you know, she only took 50 pennies and she happened to get 11. So that's another thought of like, not every single sample you get is going to be a great representation. Sometimes randomly we just get wacky stuff. So let's think about this way. For the next question, it says, what are two possible explanations for the evidence that she got? So explanation one is always that like, well, the actual claim is true. So like, I mean, it could be 13.2% of pennies, but she just happened to get a weird number. So that's option one. So the actual claim is true. Boy, the stylus is writing rough today. And then the other thing is that the actual claim is not true. So like her sample, you know, maybe it is a good reflection of the population and there are more pennies because her sample had so many, you know, copper pennies in it. So those are kind of our two options, right? We've got, it could be right and her sample's just weird, or it could be wrong and her sample is telling us something because it did have a lot more pennies in it. So let's actually look at a sampling distribution. Let me move these around a little bit so I can see them better. So we've got, so we did it with a computer. We didn't want to have Jenna go out and get 50 pennies all the time. So we used a computer to simulate, just like with the rolling of the dice on Wednesday. We used technology to simulate selecting 100 simple random samples of size 50. So we want to use this sampling distribution to take a guess at where we think the true proportion of copper pennies is actually at. So we've got 100 dots here, but as a statistician, you have to think about one dot at a time. So like, what does one dot on this, you know, sampling distribution mean? If I had to make a key for this and say, okay, this dot equals this, like this is what this dot means, describing it in words to someone, what do we think? Let me call on someone. Tesla, what are your thoughts? What would one dot here? How would you describe it to somebody? If you had to make a key. Do you mind unmuting yourself? Doesn't have to be right or wrong. We're just brainstorming.
It would mean that like one of the trials to like 22% of the pennies are pre like 1982, I think.
Yeah, so here's Jenna's dot. So one sample had 22% of copper pennies. Now, the only thing we want to add is one sample of size 100. You always want to say how many pennies are in that sample. Okay, so that's that. So we kind of have our picture here. We did this on the computer 100 times, and we can see, like, here's Jenna's result. So remember, we've got two options. Either there are 13.2% of copper pennies out there, so like the true proportion is 13.2%, or it's not 13.2%. Those are our two options. So Jenna's result is there, and didn't come up a whole lot. So when we sampled this, simulated it 100 times, like these are kind of the common values, and this is her value. So let's go ahead. We're questioning kind of her result, because it's like, ooh, that's a lot bigger. This is a lot bigger than, you know, what we're thinking should be there. So assuming, let's go kind of into the logic here. This is the part that might get a little sticky for some of you, and that is okay. If it is sticky for you and you're like not sure what I'm saying right now, I can repeat it to you a lot of different ways. We usually have a great debate about what we should do with these two questions when we answer them and how we should think about it every year, because it is a little confusing to think sometimes the way with the stats find. So feel free to ask any and all questions at this point once we're kind of going through this. I have learned to reword this quite a few ways. So, all right, we've got our sampling distribution. We got to use the thing. So two things you always want to look at is like, okay, where is my result with respect to everything else? All right, well, my result that I got only happened one time when we simulated things. Okay, so that should be a little bit strange, because it's like, if the pennies out there are what they say they are, then my result should be more common than what it is. So first red flag is that my 22% really didn't show up a whole lot. So that's a little weird. Then you also kind of want to look at just in general where the dots are. So we can also kind of see that. So, so for question 5, assuming that 13% of the pennies in circulation, so assuming the claim is true, we don't really have anything else to go off of. We kind of have to just assume, we got to take it for face value. So assuming the pennies pre-1982 are that, is it surprising to randomly select you know, a p hat of what Jenna got? So is this a surprising thing that she got? So we got one dot to happen here. So, and we also kind of think about like, all right, well, what is as unique as me, but what, like, are there any other dots that are kind of close to me? Like, did anything else happen? So basically, as a statistician, you would look at, all right, what's the chance of getting what Jenna got or greater than what she got? Like, you know, because if she got a pretty wacky number and it was pretty big. So we have 4 dots out of our 100. So there's only a 4% chance that I'm going to get what Jenna got or greater than what Jenna got. So how do we feel about 4%? Is that in general, just thinking about probabilities, is 4% a high probability, a low probability? How do you feel about that? Call on some people here. Cheyenne, how do you feel about 4% odds? Like, if I told you you had a 4% chance of getting this, would you feel good or bad about it, just in general? What do you think? Do you mind unmuting?
Probably bad, because that's a very low probability.
It's not great odds, right? So what Jenna got is not really what Jenna got, or even if people, you know, get greater than what she got, that's not super likely in this case. So is it surprising that she would have gotten this if the pennies out there, you know, if our original claim is true, only 13.2% of pennies, you know, are copper, and she got 22%, there's only a 4% chance that or anything greater than that happens. So not great odds. So we should be a little surprised. Oh my, her result is unusual. It's not really happening a whole lot. If her result was a common result that just like randomly came up a lot, then we'd be like, okay, yeah, we feel pretty good about the original claim. But right now we have to be questioning like, oh, the result I was questioning that I was like sus about also isn't coming up a whole lot when I do this with the computer. So that is also a red flag of like, she got her result, but it also just, it's not, I'm questioning it, and I should still be questioning it because there's not a high chance that I would get that. So here's where the stats stuff comes in, and this is where sometimes where people get confused. So we have to decide as a statistician, have I convinced myself essentially that Jenna's numbers are weird? Like the thing that she got is off. And because that's off, my original claim might not be true. So going back to our claims, it's like, well, either the claim is true and the proportion of pennies is 13.2% that are copper, or it's not. So I have found some evidence now. Her result or greater than her result is only a 4% chance. So in terms of the stats world, our cutoff for deciding if a probability is weird is 5%. So on this one, I would say, yes, I have convinced myself that her result is weird, because it doesn't happen a whole lot. And I've proven that it doesn't happen a whole lot out of 100 different, samplings that I've taken. So if that's the case, then I'm going to go with the first option. As a statistician, I'm going to say I have convinced myself that since her thing that happened shouldn't happen a whole lot, and it did happen, like there's a low chance, the original claim must not be true. So I've convinced myself that there are probably more, probably more than, well, let's not say more than, hold on. So I'm going to say yes. Oh no, they did say more than. There are more than 13.2% of copper pennies out there. Since her result was unusual, and it remained to be unusual when I simulated it 100 times. It didn't happen a lot. So if the thing you're questioning does not happen, or it happens less than 5% of the time, that to a statistician we go, ooh, that's weird. So my original claim is probably not true, because I didn't find any evidence that says that that thing should happen over and over. Now, if we would have had a bunch of dots here, like all of a sudden, if I got 22 to happen a whole bunch of times, then I would have been like, oh yeah, okay, well that, by random chance, that happens a whole lot. So my original claim is probably true. If the result you're questioning is still coming up a lot, but if it's not, then you have to still question it and go, yeah, it's less than 5% chance. So that original claim with the pennies is probably not true. What questions do you have? Because at this point is usually when people debate each other in class and they question their whole life and everything about it. Because that thinking sometimes is a bit strange, but this is what we're going to go with, because when I examined my result, I still proved that it continued to be unusual. So my original claim, I'm tossing it out. There's more than 13.2% of copper pennies. What questions do we have? Feel free to put them in the chat. It's probably a little quicker if you unmute yourself and we can talk about it. Instead of me reading words quickly, but what questions, you can raise your hand and I can call on you. If you're not sure what your question is, that's another popular thing. People are like, yeah, I have no idea what you just said. That's fine too. I can try to re-explain it a different way. So raise your hand if you have questions or you are confused. Most years people are confused. So you are in that boat, that is fine. I'm just going to keep drawing until, in case someone's typing, because I don't know that I've ever gotten through a year where nobody's questioned what just happened. It's harder virtually because I can't look at your confused faces. Maybe you're all asleep. I don't know. What is number 2 again? Like, oh. Wait, this number 2? Or, yeah, oh. Number 2, So basically, great question. Thank you, Tessa. So great question. So number 2, I'm like basically, I'm gonna go back to number 1 actually. So basically, I'm taking inventory of my information and I'm saying like, all right, here's my population and here's what I'm thinking is true about it. And here's my sample and here's what I got. Whoa, like my sample is way off from what the population should have been. So that gives us some sort of evidence of like, yeah, well, my, the population was that, and my sample is that, and those are not the same number. So that gives me some evidence that I'm starting to question this 13.2%, because if that's true, then why is my sample so far off? If this is the true proportion. Yes, Cheyenne. So basically, to a statistician, if you're questioning a result and then that result is not popular in your sampling distribution, not popular meaning happens less than 5% of the time, then you're going to toss out whatever original claim you made. Like whatever you assume to be true is not true. So in stats, it's always a 5% is our cutoff point, but that is a little weird for people. This is where the debate comes in. People are like, well, that's a little strange because like, what if it happens 6% of the time? 6% of the time is crappy odds too. Well, yeah, it is, but not to a statistician. We had to come up with a cutoff point, and we all agreed that 5% was where it was going to be. So now, if I would have gotten basically 2 more dots, in this box here, then I would have been able to say, oh yeah, okay, well, now it's greater, it's greater than a 5% chance that result happens, and I feel okay about that. So yeah, so anything over 5 is your original claim is good. If it's under 5, you need to toss out whatever you thought was true. Yep. Okay, great. Any other questions? I did drop the practice problem in the chat, so if you want to open that up, and if you're feeling all right, you can start that. Any other questions for me right now? Because this is a little weird to think about sometimes. But this is the same. We're going to use the same logic all semester. So if you are still a little lost, that's okay. You're going to get it a whole bunch of times. You're going to 5% cutoff. You're going to just. Okay. If you don't have questions, I dropped a practice problem. Oh, allergies today. In the chat, it's essentially the same thing we just did, just with like poker chips. So open that up for me, and if you've got about 7 minutes, I would love it and appreciate it if you could get this one done for me, just so I can see where your understanding is. If you're 100% confused yet, that's fine too. Just take some guesses. That'll help me as well, kind of figure out what I need to adjust kind of going into next week and how I need to word things, because this is all about wording. So if you could give this a try for me once it's done, it's same 5-6 parts that we just did. That I'd much appreciated, because that'll help me adjust. Since I can't see your faces, you're gonna have to do a problem for me so I can see where you're at. And then once you're done, you can pop off for the day. So you got about 6 minutes officially, but you're all at home, so I guess technically 11 minutes until the next class. But go ahead and start this practice problem if you can here. Much appreciated. And then you are good to go once you've tried it. It doesn't have to be right. You're just trying it. So I dropped that in the chat. Go ahead, try that. Also kind of sharing it out via the Blocksy. Kind of weird. Give me your best guesses. Then I know how to adjust. And then when you're done, you may pop off. watching you on the Bloxy though, so don't try to fake being done. Try to actually do it. Love you all.